Good afternoon, everyone. Thank you very much for joining us this afternoon. We will start shortly. We're just waiting for, one of our speakers to join, and we wanted to also allow attendees to join the call. My colleagues will take over from me, but really glad that you could join us for this launch of our BESS working group this afternoon. Over to you, Snetemba, to get the meeting underway.
Thank you, Tavi. Thank you, Tavi. And just good afternoon once again to our colleagues. We've seen that our speaker is in the call now. And just thank you once again, colleagues, for joining us today. We have over 60 attendees in this call. And I would just like us to start with the housekeeping rules, which are pretty much quite on your screen right now. I basically would appreciate if everyone would keep their microphones off for the entire session, at least until we do our Q&A. If we would like to ask any question, please feel free to raise your hand, or ideally you can also type it for us, and also given an option for you to email it to us as well. This session is recorded, colleagues, so we will share this presentation from all our speakers that will present for us today. And once again, just thank you. And I think I would like to just take this over to our next colleague who will do the next item, which is for us to look at today's agenda. So for today, we will cover we'll have a welcoming to market creation lessons, which are from an African perspective, from both the solar and utility, as far as BESS is concerned. The third item on our agenda, we will look at market insights from South Africa's and also a global perspectives value chain, including localization and job opportunities that are within the sector. And our last speaker will cover power quality on distributed energy resources, as well as PV, including BESS, especially into the grid infrastructure. Lastly, we will do a Q&A segment after all our speakers have presented. And furthermore, we will take this opportunity for today's proceedings to introduce our guests, as well as looking at other focus areas and objectives for this working group. It's quite exciting to have our speakers for the day. And we also just look at how everybody else can be involved in the working group, and also all of the other activities that we'll be doing from then onwards. And we will close this session there afterwards. Thank you, colleagues. I think I'd just like to hand over this to the next agenda item on the call.
Snetemba, if you can just drive the slides.
Okay, we'll do that for you, Sim. And over to you, sir.
Good afternoon, colleagues. I see a number of colleagues are still joining, but I guess we can just continue, and they will catch us as we continue. My name is Sim Kuluse, and I am the Technical and Policy Manager within Savia. And I think my role is really simple, is to welcome you and obviously give a little bit of context about Savia and the working group. And I think that's my role. If you can just please go to the next slide. Just a little bit about Savia. We are a true voice of solar PV industry in South Africa. We represent members, over 500 members across the solar value chain. Our members bring together, like I said, across the whole value chain, brings together installers, manufacturers, developers, researchers. And in fact, I think in the next slide, I'll give you details and the breakdown of our current membership. What we do with our members, we work together to drive policy, we set industry standards, and we really about accelerating the solar adoption in South Africa. And our vision, colleagues, is to really see this technology, which is solar PV, including BESS, being a reliable and significant contributor to the energy mix of South Africa by 2050. I dare say that in terms of renewable, we are currently leading in the country, and we are already, there in achieving our vision. And our vision is really supported by 3 pillars. We believe in energy security, and we see we are about to harness or about harnessing the solar resources to ensure that we deliver the reliable energy for every citizen in this country and every industry, and that electricity or energy has to be clean. And how do we do this? We believe that there has to be an alignment between the market and policies. It is our aim that we always have clear rules, clear laws. That is why we work together with government and industry or private sector to actually make sure that the environment is conducive for investment and that the regulations are clear and they are not restrictive. So there has to be a collaboration between the government and the private sector. And the third pillar is really about environmental and market sustainability. We truly believe in green economy that works for everyone, for all our people, for the country. We believe that our technology, including BESS, has a huge role in decarbonizing our grid. But while we do that, we need to ensure that there's economic development and that there are job creation in South Africa. If you go to the next slide. It's not moving on my side. Okay. Our members, like I said earlier on, we represent over 500 members, and our members come from project developers, the IPPs or independent power producers, EPCs or engineering and procurement and construction, operations and maintenance, the manufacturers or OEMs, installers. We have trainers or training centers, consultant researchers, and financiers or banks. On the right of the slide, these are some of our members. Those are our sponsor members. Currently, we have 7 sponsor members. Next slide. And we have full members. I'm not going to move to the next slide. I think of the associate members, those are associate members. Next slide. Another some of our members. Yeah, thank you. Really, the background and the context is simple, colleagues. For us, we see BESS or battery energy storage systems as providing reliability of electricity supply. We know that our technology has one Achilles heel, that is intimacy. So meaning we generate during the day, but at night or when it's cloudy, we are obviously not generating using solar PV technology. So BESS then supports our technology in providing continuous dispatchable power on demand. And we are establishing this working group to actually make sure that there is collaboration among industry players and stakeholders in driving policy, standards, grid integration, localization, and skill development. We believe that we need to come together to tackle challenges that might be facing industry around the issues of BESS. We believe that we need to come together to develop uniquely South African best practices. Next slide. It's not moving on my side. Oh, no, thank you. That's thank you, Senator. Back to you.
Sinatemba, your microphone is
Sinatemba?
off.
Thank you, colleagues. I'm just speaking on mute here. Apologies. Our next speaker on this particular segment, I'd like to introduce Mr. Felix Kembo, the Utility Manager at Global Alliance for People and Planet. Colleagues, just maybe a bit of background. Felix is an energy specialist, is quite experienced in the battery energy storage industry across Africa and Asia, and he has coordinated quite a vast number of projects ranging from $20 million in project valuation, ranging from 20 to 40 megawatt hour projects in Malawi, funded by the Global Energy Alliance, and has managed more than 1.5 million in storage studies and training programs. And he has recently led the establishment of a Battery Energy Storage System Center of Excellence in the Southern Africa. So he is well placed to share his practical lessons on building these markets from an African context. Felix, without any further ado, please feel free to share your presentation with us. Thank you.
Thank you very much. Let me just share my screen. I hope you're able to see my screen from there.
Yes, we can see it.
Okay, thank you very much. Yes, so maybe to save time, thanks for the introduction. That covers exactly what I do at the Global Energy Alliance for People and Planet. But just to give you an introduction of who the Energy Alliance is, we are basically a philanthropic organization that is focusing on carbon access and jobs, and those are our impact focus areas. And we do this through market shaping. We also look at government enablement, and then we look at catalytic financing. So these are the our three levers when we go into a market or when we go into some geography. That's basically what we do, and we do have two pillars. There's a grids of the future where we're focusing on base and grid digitization, and then we also have a powering opportunity and energy where we're looking at DRE and productive use. So we are in Africa, India, Southeast Asia, and Latin America. We just to give you the background of what we've been doing. So over the years, we've been looking at the grids in the global south. Just look at the constraints that they're facing, and we have noted that the system is the same where you have back and film power moving from in one direction, but then there is lack of grid flexibility and lack of grid visibility. So the system is unbalanced, especially when you come to renewable energy, especially solar and wind. So you have curtailment and system balancing issues. And then you also have lack of grid visibility and control, like system losses. You're not able to get a clear picture on what is happening on the feeders. And so you have some assets also that are underutilized. Other transformers are overloaded, others are not. So that kind of visibility is also a problem. So For BESS, we're basically fixing the issue of grid flexibility, and that's what we've been trying to do to make sure that we can support system balancing in these grids. On the Energy and Opportunity Awake, just to say that we also focus a lot on these DREs and productive use of energy, where we're looking at solar powered irrigation, we're looking at refrigeration, agro-processing, and cold storage. So we do a number of initiatives there to support SMEs, to support the private sector, peer-to-peer exchanges, trying to replicate blueprints. So we are doing a number of things. In Haiti, we're doing solar mesh mini grids, and we're also doing a number of things in Nigeria, in Ethiopia, in Kenya, in India, in Indonesia. So we have a number of initiatives that we're doing on productive use of energy and solar powered irrigation, refrigeration, and agro processing. To kind of like save the time, so we at the Global Energy Alliance, we have what we call the BESS Consortium, which is a consortium of partners, the World Bank, African Development Bank, and a number of partners that we're together trying to support battery energy storage projects. So we do have others which are IPP partners, others technical partners, others are utility partners. We have a number of projects that we are looking at for BESS, like in Honduras, in the Caribbean, in Barbados, in Colombia, in Brazil, in Malawi, in West Africa. We are also thinking about the Western African Center of Excellency. We have a BESS pre-feasibility study that has been done for the state of Cape Town, and we are also looking at how we can progress to feasibility studies, and some work in Vietnam, in India. And basically what we are looking at is having a global knowledge platform where we'll have all the information about BESS, so you'd be able to get everything that you need from there. Now, going to the project that we wanted to focus on today, for Malawi, we have done a project from inception, from initial studies to modeling up to doing an RFP and commissioning it. At the moment is undergoing commissioning stages, so they are injecting into the grid, but we're waiting for I think the final phase that they are trying to do is to clear the snag list, especially with SCADA integration. So what happened, like in this example, is that for Malawi, we noted that their grid was mostly hydro, but then due to a cyclone, they lost 1/3 of their hydro capacity. So because they had added a lot of solar, now in comparison to the firm capacity of the grid, solar was leading to a lot of system shutdowns because it wasn't backed up by batteries. There was one little solar that had, of course, like a behind the meter battery, but it wasn't sufficient to kind of like support the disturbances to the grid. So obviously, as a utility, let me just go back. As a utility, they had to kind of like curtail, and then obviously that led to dimmed energy charges. You had high cost of picking diesel that they were incurring. So with that, we ended up providing catalytic capital to support procurement of the EPC contractor and owner's engineer. And of course, ESCOM, the utility, supported with project management in Asia. And with that, we're able to do the feasibility studies in terms of looking at ways to replace the diesel generation and then modeling the base in terms of the sizing and the location, which are the key studies that we look at when you're looking at base, is to see what is the sizing and what location is feasible and gives the grid a lot of benefits. And of course, you also look at the use case, and then we supported the procurement support in terms of RFP for the Asia expert and EPC contract, and then of course O&M service. So at the end of the day, you have capacity building that you're giving to the utility, and then they also have O&M data that we'll be able to publish through what we've established as a Center of Excellence. A number of outcomes that are there, some of them are public documents. So we have procurement documents. You'll be able to access procurement documents from this project. Not only the RFP, but you can also access like the questions, the requests for clarifications and the responses. You'd be able to access the studies. You'd be able to access key documentation from the project, but we are also looking at the benefits that we've got from this in terms of savings from displacing diesel generation, reducing dim energy charges, improved voltages, reduced curtailment, enabling more VRE now, especially in the afternoon. They're able to not curtail, but allow the VRE to kind of like inject into the grid without suffering dim energy charges. There's also an export potential once Malawi is connected to the Southern African power pool through the Malawi-Mozambique interconnector that is going to be ready either end of July or somewhere in August, but at least in this year, in the third quarter of 2026. The key lessons that we have learned, I'll just, I'm sure this presentation will be shared. There's a copy that was sent, but just to say that during project development, you have to be filming your studies because that's one thing that we have learned, that if you're not filming your studies, you might bring in the owner's engineer, but the owner's engineer will be able to say, look, I still see some gaps here. So that's one thing that you have to be filming your studies, especially the location, the sizing, and the use case. And then, of course, you also have to understand the project, engage the parent ministry for policy, because we conceived this project, we saw the need, but at that time, the grid code didn't have provisions for utility scale BESS. So you have to engage the regulator and the Ministry of Energy to say, look, the policies are not there. So you kind of, there's one phase where you have to wait for policies to be developed, and then there's another phase where the moment you're implementing the projects, somehow it brings in the need for policymakers to sit down and quickly deliver, quickly provide the policies and regulations. So, and that's one thing that we saw in this project. So you'd have now a grid code provision for. Let me just go back. We had a grid code provision for BESS, and we had a number of they are currently looking at what would be the right tariff structure for such a BESS, looking at the difference between cost plus, which is normally what is done for generation projects, and comparing that with the benefits that you get from the BESS. In this case, we're calling it value plus. In the procurement, we're using public procurement rules of the utility, but we noted that one of the things that the utility would have to consider sometimes is the quality only evaluation, where you're only looking at the quality and then you negotiate the price afterwards, just to make sure that you get quality experts or owners engineers. That helps. If you're also looking at international tenders, obviously engage partners that can try to advertise internationally so that you get the international response and quality response as well. Bidding documents obviously have to be as specific as possible. I think when looking at the project from inception to the end, you could see that there are some things that were given as options, like you give the EPC contractor an option to choose, but then when during implementation you realize that you probably prefer something else, and the contractor chose something else. So those are things that we, at the end of the day, we kind of like say, I think it's good to kind of like be specific on some of the things that you read. It might be as small as the road structure. Do you want tarmac road? I mean, do you want asphalt? Do you want cement structure? Those are things that you may think are easy, but at the end, if you prefer something else, then obviously you're attracting additional costs in terms of an EPC addendum. I mean, having deliverable-based contracts as opposed to time-based contracts, sometimes they help, especially if you're dealing with owners, engineers, or other consultants in these projects. But sometimes there are things that delay. As we looked at the contractor supply chain, Malawi being a landlocked country, the contractor had initially planned to deliver the materials through Tanzania, but then at the time at which the material was supposed to be delivered, the containers through Tanzania, there were some issues in Tanzania in terms of political unrest and demonstrations. So that means you have to kind of like shift to say, okay, let's go to the port in Mozambique. So all those are things that you kind of like have to regularly look at. There are things that sometimes you plan on airlifting materials, but then you realize that maybe the first flight from one destination to the other can allow a certain type of cargo, but then from one destination maybe to where the materials are required, they would say, no, you need to break up these components because the flights that go to these areas are smaller. So those are things that you kind of like have to clear in advance, and also try to look at the sequencing properly, especially when you're dealing with experts that are coming at the site, whether they are BESS experts or whether they're SCADA experts or whether they are GIS experts, or you kind of like have to make sure that you align and sequence everything properly if you want to get maximum benefit, but also make some savings from the way you're implementing it. And you also regular meetings. I mean, sometimes when you're implementing these projects, you look at a case where you think there's nothing, we're just waiting for procurement. But the moment you initiate progress meetings, even if there seems to be like nothing, you kind of like end up pushing some smaller things that in the end open up a door to most of the things that are bigger. So that's one thing that we have learned in project management, and and this is critical, especially because when you're doing the designs, of course, you start with the base. I mean, the items that have got a longer lead time, like the manufacturing timeline, but then you kind of like also don't have to lose sight of the other items. Like in our case, we somehow GIS delayed more than the batteries themselves. So those are things that sometimes you can ignore, but then you realize that the gas insulated switchgear was something that had to be prioritized as well by the time we were finishing the designs for the base. So having a dedicated project manager, I mean, when you're dealing with utilities, obviously there's a temptation to utilities to have one project manager dealing with so many projects. But if base is new, you kind of like want to request for some more dedication. So that also helps. And if you're managing the relationships, keeping a register for the contracts, insurances, because sometimes projects they so have everything ready, the permits and all that. It's also nice to have participation of local firms. So make sure the two others clarify that, so that you also give expertise to local firms in terms of base as much as new technology, but at least they let them have there's some things that can be done. I mean, locally, they may not be able to kind of handle maybe the containers, but at least there's some things that the electronics, the civil works, some of the mechanical work can be done by local firms, and to make sure that it's not just a mention, but they actually come in to participate. Just quickly say about the Center of Excellence. So through this project, we as the Alliance, we're setting up centers of excellence. At the moment, the Southern African Center of Excellence is operational, and the idea is that it will be sharing knowledge from various projects that are happening in Africa, providing training, certifications, and they'll be analyzing data for the O&M from the projects, supporting with power system planning, giving operational guidance, templates, policy and regulator support, and what have you. And we are looking at having a Western Africa Center of Excellency in Q3, so that it's also tackling projects in West Africa. And then all that feeds into the BESS consortium knowledge hub, which is a hub for all the BESS projects that we can get with templates and lessons for investors and developers and regulators to get insights into. In terms of the grids of the future, this is what we are looking at: a grid where things flow. You have storage, low transmission losses, SCADA is operating, you have demand is flexible, you have assets are purely digitized, you have smarter decision making, you have enhanced visibility and forecasting of what you're generating, for example, solar. Everything is done intelligently. It's flexible. DRI is able to integrate into the grid. It's combining transparency, innovation, and dynamic solutions. So that's basically what we're looking at into the future when we look at a grid of the future, from generation, transmission, distribution, and then to a place where you have prosumers. That's what we're looking at: base and all solutions. Lastly, as I close, this is a website of the Southern African Base Center of Excellence. It's currently hosted at Nzuzu University, but Nzuzu University is currently forming partnerships with a number of institutions, including the Faraday Base Institute from the UK. They have a partnership to support the same, and I think they'll be in Kenya for a conference to look at these things and how they can support other projects or developers that are interested to learn from BESS or access studies, access templates, access RFPs, access all key documents, and look at what can be done for the BESS. Thank you very much. I'm happy to take questions or maybe wait until the end.
Thank you, Felix. Just like us to move into the next segment, we'll take questions at the end. Thank you once again, Felix. I think as we move to our next speaker, Mr. Ishrat Kathrada, the Chief Executive Officer of the Local Support Fund, please let's give him a warm welcome. The LSF colleagues develops, industrial opportunities in South Africa, and he has previously advised the national minister responsible for trade and industry and spent close to a decade as well in the investment banking with JP Morgan in New York and London. He has also founded a fintech company which led finance for a climate tech business in the UK. And also he holds an MSc in Sustainability Enterprise from Oxford, which gives a strong view on the value chain and where the local opportunities sit. Mr. Ishrat, the floor is yours. We've got 20 minutes there. Thank you.
Thanks so much, Sinatebe. Thanks so much for that introduction. I'm going to share a presentation from my side. So if I can take the opportunity to kick you off and share mine. And just pop it into presentation mode, and it looks that that's visible on your side. So thanks again for this opportunity to engage with the workshop. I mean, let me start off by congratulating Sapvia on this initiative for establishing this workshop and this platform for engagement. I think platforms of engagement like this are incredibly important. And I think as we'll go through the presentation today, you'll, I think, hopefully all recognize the immense opportunity that the battery value chain offers for South African industrialization. And again, these type of platforms are incredibly important in unlocking some of that opportunity. So let me start off. There are about 5 things I really want to touch on over the course of the 20 minutes that I have available. Just who we are as an organization, as a starting point. I think we'll be a relatively new organization to some members on this platform. We'll then look at the BESS market and the development thereof. I want to touch on some of the technology choices that we see some of the stakeholders making in respect of battery storage systems, where we see some of the localization opportunity, and then, of course, what is needed to unlock those opportunities. So let me start off with about who we are as the Localization Support Fund. We're a relatively young organization. We'll be celebrating our 5th anniversary a little bit later on this year. We're effectively founded as a partnership between government and the private sector. So we're a non-profit company. We're what's called a public benefit organization. And we're founded between the DTIC, the Department of Trade, Industry and Competition, but funded by the private sector. Our funding comes from the likes of Coca-Cola, from Air Liquide, from Engen. These were all commitments towards industrialization that came out of competition processes. So when the Competition Commission looks at mergers in the economy and tries to assess whether that merger will strengthen local industrialization, one of the things that they've done with a number of parties is trying to get commitments towards localization, industrialization. And in effect, that is what the Localization Support Fund is. We partner with a range of different stakeholders, from manufacturers, SOEs, private sector, industry associations, and government, in order to unlock the opportunities that might be in the South African economy. And we do so through 3 integrated capabilities. The first is research. We commission research in respect of where opportunities are, but also how do we translate those opportunities into actionable policy and industry outcomes. We're looking at, identifying what there is on the table, what the obstacles are, who the right stakeholders are, what the unit economics looks like. Effectively, that's what we want to try and understand. The second area where we get involved is in what we call capacity building, where we have in the past deployed process engineers, industrial engineers, chemical engineers into businesses across South Africa so that they can scale up to meet some of the industrial outcomes and demand that there is. Through that work, we've helped to localize about 200 million rands worth of production that was previously being imported, but is now being manufactured in factories from Cape Town, Buffalo City, KZN, and Gauteng as well. We've also worked with some of the state-owned enterprises and private sector companies in order to help them strengthen their procurement functions and align their procurement strategy to an industrial strategy, one that is not just transactional, but is strategic as well. And the final area where we get involved is what I'll call industrial facilitation, which is really trying to link the value chain together, where we identify gaps, to work with our networks to identify potential manufacturers who could come into supply chains to produce any good that might be required downstream. Now, we publish all of the work that we do, and it's all available on our website. The website is there, and I'd really urge stakeholders to have a look at that. We've done 3 pieces of work in the broader battery value chain in South Africa, all published on our website. The first on the far left, and sorry, it's a little bit small, was some work that had been commissioned by the South African Renewable Energy Master Plan, SAREM. The Project Management Office asked us to look at 3 key value chains, battery, wind, and solar, to identify where the localization opportunities are. And that fed into the development of SAREM, which was adopted by stakeholders last year. And all of that work, both the work that we've done on batteries, but also the other value chains like solar and wind, is available on our website and was published in late 2023. We also published some work late last year on the vanadium redox flow battery value chain, also trying to understand where the opportunities are for industrialization. As many of us will know, South Africa is endowed with significant vanadium mineral resources, very, very rich, low in impurities. And there has been some work to try and turn that into some of the precursor materials that goes into VRFB batteries. And so we were looking at the ability for South African industry to compete and where pricing is going. And again, that's published on our website. And then the most recent piece of work that we've published on our website was a feasibility study we looked at into battery cell assembly in South Africa, particularly for LFP, lithium ferrophosphate batteries. And again, that's published on our website, and there's been quite a lot of stakeholder outreach in respect of it. The presentation I'm going to go through today is in effect an amalgamation of some of the work that we've done over the course of these 3 studies, but also some of the work that we've done with the JET IP office in the presidency in support of some of the battery strategy that we have there. So let's start off. Where is the market going? And I think this is really, if there's one thing I want to take away today, is just the immense growth that we're seeing. So this comes out of the work that we had done in respect of the feasibility for LFP battery assembly in South Africa. And critical to that feasibility study was trying to understand what is the direction that demand is taking in the South African economy, and where are we seeing those different pockets of demand come from. So at the moment, there's about 5 gigawatt hours of demand in South Africa, predominantly in the BESS sector. That's your darker green that you have over there. But we're expecting that to grow considerably over the next 10 years to about 55 gigawatt hours. Now, that is broadly in line with where global trends are going. Sinetemba, you started off this discussion by saying that as we roll out renewable energy resources in order to stabilize the grid, noting that the wind doesn't always blow and the sun doesn't always shine, we need to be rolling out batteries alongside it. And that is exactly where we see most of the demand coming from. You know, in South Africa, we tend to talk a lot in the policy space about what we can do to develop NEV battery manufacturing capability. But really, where we see the majority of the demand coming from is actually in the BESS sector. So of the 55 gigawatt hours of demand that we are projecting over the next 10 years, 49 gigawatt hours. So, you know, roughly about 90% of that is coming from the BESS sector and growing at a considerable rate of about 30% year on year. Now, we can see actually, if we double click into this, where that demand is coming from. So forgive me, this is a very, very complicated slide, but I'll try to simplify it as I talk through it. On the left-hand side, we've broken up that demand into where we see demand coming from in the South African ecosystem. And then we've also looked at where's the opportunities in Southern Africa more broadly, because of course, whatever industrial capability we're able to build in South Africa, we need not only look at the South African market, but also some of the export opportunities that might exist. And Southern Africa is one of those key areas where we believe there is an opportunity to export some of the technology. Most of the demand is coming in South Africa. About 32 gigawatt hours of demand for BESS is coming from South Africa. But what's really interesting when you break this all up is where that demand is coming from. About 15 gigawatt hours is coming from corporate and industrial. These are private sector clients, your miners, your agriculture, your farmers, and other large industries that are beginning to invest in their let's call it off-grid energy, of which batteries is a significant part. And we've seen quite a lot of demand that's grown over the last number of years in that area. Utility is also an incredibly fast-growing area of demand, and that's going to be largely driven by Eskom, but also the IPP program that is enabled through the REAP program of Eskom, and then of course residences as well. As battery technology becomes cheaper, more accessible, and affordable for residences, we're starting to see that move, and that will also make up a significant chunk of demand. This thin sliver that you see in lighter green is where we see demand coming through from the NEV market. Now, the expectation is that over time, NEVs are going to grow, but it's really BESS that we think is going to anchor that demand in the short term. You see a similar picture that's emerging in respect of Southern Africa. The numbers are smaller, roughly about half of what we're going to see in South Africa, but equally driven by BESS. But there we think utilities are going to take the lead in respect of where the demand is coming from. And that probably makes sense in terms of the maturity of the relative markets, both in South Africa and across Southern Africa. So really, I think, again, I want to stress there's a huge amount of demand that's coming through. And I think with that demand, it does start to create the scale where localization across the value chain starts to become much more viable. I think the other thing that we've seen, and as I said, we had commissioned one study in 2023 that was conducted by BMA, and we conducted a further study that was conducted by EY in 2026. So there was about 2.5 years that separated these two studies. They had a slightly different scope in respect of what they were looking at. So in the BMA study, we were trying to identify where localization opportunities were across the full value chain. In the EY study, we were really focused on LFP battery cell assembly in South Africa and whether or not there was a commercial case to be made. But there was one critical thing that I think came out of this, which is that even our rosiest forecasts in 2023, by the time we did the study in 2025, we had realized that we were far too conservative. And I think for me, one of the things that comes out of this is that technology is moving very, very quickly. Price points are moving very, very quickly. In fact, if we've had a look at some of the anticipated rollout of wind, solar, and battery technologies and some of the forecasts that have been done over the years, we have far exceeded that, even versus the most aggressive forecasts. And that is because there's just been so much investment in this technology and it's so necessary. And as it becomes cheaper, there's even more investment and even more rollouts. And so we're starting to see this sort of multiplier effect. And so, we've spoken a lot about batteries. I think one big takeaway for me is that the market is moving a lot faster than policy is at this point in time. And this is, again, why I think platforms like this that can understand the landscape and advocate for what's needed, bringing in the right partners is incredibly important. So I think, that's a key takeaway that I wanted to get. Let's talk a little bit now about where we see the technologies going in the market, because of course that lends itself to the localization opportunities. Now, this is a slide that I think some of you might have seen in different forms, but this was prepared by the JET IP office in the presidency, looking at Southern Africa's battery mineral endowment. And we can see that across both South Africa, but some of our neighbors as well, we're endowed with many of the minerals that would feed an array of different battery technologies. So from manganese and cobalt, which is really important in NMC technology, to lithium, iron, phosphate, very important in LFP technology, to also some of the vanadium that would also be important in VRFB technology. South Africa and our neighbors have a lot of that mineral endowment. Now, this was prepared when we went to Europe. We were in Germany a couple of weeks ago. at the battery show. So it had a very European focus because we recognize that there is a lot of interest in sourcing battery grade materials from South Africa to support Europe in what they are calling strategic autonomy. It's a recognition that just sourcing from China or parts of East Asia, or even relying on the United States as a trading partner, has risks. And so EU is looking to diversify itself and looking to Southern Africa as a strong partner. Now, not only do we have these mineral reserves, but the quality of a lot of the material is phenomenal. So I've spoken a little bit about the quality of our vanadium material, but I could say similar things about our fluorspar, our phosphate, our graphite. There's a lot of high quality rock and ore that's sitting there. A lot of the work we've done has suggested that to produce battery grade materials at scale, it will require significant investment. And with significant investment, you do need to ensure that you have good market access. And that's part of the work that we're trying to do with the EU and other trading partners to help build a value chain that is not just trying to focus on the South African market, but focusing on abroad. Now, this bit of work comes from a piece that we had done and published last year on vanadium redox flow batteries, and hence you'll see the thick red line around VRFB. What it's trying to show, and this has been published on our website in October last year, is we asked the service provider, look, please do a benchmarking of where VRFB would measure versus other technologies that are out there. Because some of the debate that I've heard is this an LFP versus VRFB versus NMC type of approach? And will South Africa need to choose and back one horse in its technological journey? And I think that based on the work that you see here, and this is just a subset of it, I highly recommend that you go into the report. We've got a double pager looking at an array of different technologies, from some of the lithium-based technologies to vanadium to ferrochromium, zinc bromide, etc. Is that different batteries offer different advantages under different scenarios. And I think that's incredibly important because as we build out the BESS storage, both in Southern Africa and abroad, we will probably find that different kinds of batteries will perform in different ways. This market is huge. This market is massive. It's growing very, very quickly. And so this is not about one horse versus another, but it's about trying to build the capability in some of the key technologies where we believe there is significant growth. And that's why a lot of our work has looked at not only trying to identify where the opportunities are in LFP or VRFB, but also NMC as well, which is quickly growing. We're also aware of some investments that are being made in respects of iron chromium batteries, as well as sodium ion batteries as well. That's another incredibly important area of growth. The one thing that's important, though, is obviously cost. And this, again, comes out of that VRFB study. I use this only illustratively, is to show that, look, one of the key deciding factors in respect of whether a VRFB battery or an LFP battery might get chosen is, one, the conditions of use. So making sure that you got the right horses for courses, but there'll also be a pricing consideration as well. We're finding that pricing is coming down quite considerably across a range of different technologies. And for South Africa, obviously, to compete, we'll have to ensure that we're benchmarking ourselves with this pricing, which probably raises a very important point that for us to go this journey, we're unlikely to go this alone. And where we're finding that South African companies are starting to make progress in respect of developing capability, they're doing it with international technical partners. And we're seeing that across the value chain because those technological partners can help us to do a couple of things. One, it can help us to avoid technological obsolescence. And by that, I mean, as we look at all the different technologies that are out there, what we don't want to do is commit ourselves to one technology only to find that advancements and R&D that's happening in the rest of the world is starting to create shifts in the market, or indeed, different ways of manufacturing these batteries. And so that those technical partners is a really important thing that we need to have. And we've seen, again, the most successful businesses are doing that well. The other thing that having a strong technical partner can enable you to do is get access to supply chain. While we do have a lot of the raw materials in South Africa for batteries, we don't often have them in a processed grade that can easily go in. So we have phosphate rock, but we don't have the high purity phosphoric acid that is typically used in batteries. And so we'll need to be able to plug into global value chains in the starting point. These are very complicated value chains. As we, in the first instance, as we begin to prepare and build up towards where we can begin to develop some of that local capacity. I think an important thing, and this also comes from the JET IP, is, the opportunities are going to be distributed across this value chain. And I think it's an important thing for members to keep in mind. I mean, the JET IP office estimates that by 2030, we could have as many as 70,000 jobs across the value chain, with as much as 53 billion rands in GDP coming from mining, refining, the development of active materials, cell manufacturing through to pack assembly, and then various applications and the rollouts of battery management systems, be it in NEV or in BESS as well. And then, of course, there's also the opportunities that might exist in terms of recycling metals as well, which we're starting to see in a lot of other parts of the world. Instead of relying on virgin lithium or virgin vanadium, is being able to recycle these materials can ensure that we can even further localize the value chain and the supply chain. The JET IP office has also done quite a bit of work in trying to identify where we've already begun to build up capability. And so across from mining through to the downstream, you'll see everywhere in green is where we have high feasibility, and everywhere you see a tick is where already there are projects that are on the go in South Africa to develop some of those battery grade materials. So aluminium metal, we have Hulamin. Hulamin is producing and extruding some of this. And so there's work that's being undertaken at the moment to see whether or not some of the aluminium that can be used in casing, potentially some of the aluminium that can be used in the foils that surround cathodes, whether that can also be produced locally in South Africa. Yeah, and there's an array of different areas here as well. I think what this lends itself to is where some of the localization opportunities are in South Africa. So this piece of work comes out of the study which we published in 2023. And we asked the service provider to, looking at the entire value chain, begin to split them out in terms of where we think there's a high likelihood of realization and where we think it can have a high impact in terms of employment. So this top right-hand corner here, called the zone of opportunity, is that quadrant where there's a high likelihood of realization. And if we get it right, it can have a huge impact in terms of industrialization, job creation. And there are three main areas that really come out of that. It's the magnesium battery grade refinery that come there. There's also the modules, the coolings, and the battery pack casing, which can be done in South Africa. There's already local engineering capability in South Africa. And of course, our endowment and the investments that are being made in building some of that processing capability has already begun. If I look at this bottom right-hand side, which is referred to as quick wins, but doesn't necessarily have the developmental reach, there's a couple of things that are coming out there. So the work that we can do in the vanadium space, there's already some vanadium pentoxide mining that's happening, vanadium electrolyte production, which is happening in the Eastern Cape in South Africa. But there's also quite a lot of work that's going into battery management systems in South Africa. We have an array of different companies that have built up capability in Gauteng and in the Western Cape as well. And of course, given our nickel endowment, some of the precursor development of nickel sulfate is also an early opportunity, and there are companies that are developing capability there. I won't touch on this for too long, but I think this is also helpful, and we'll share the slide with the committee so they can circulate it to members afterwards. But we did do some work with the JET IP office to try and identify where are the companies in South Africa that are already developing some of the capability. We looked at two particular value chains, NMC, nickel, manganese, cobalt, and also LFP, that's your lithium ferrophosphate, identifying different cathode materials, anode materials, and electrolyte, and where we can develop some of the capability in precursors and which companies are already doing that. And you'll notice that already across, and this is both South Africa and the rest of Southern Africa, you'll notice that across many of the precursor materials that would be required for key chemistry and batteries, we're already developing some of that capability. And I think that's already very, very encouraging to see, including in cell assembly in South Africa with the likes of AfriVolt and others. So I've got just a few slides left because I know I've taken some time, but really the key question for us, and this again comes from the study that we had done on the commercial viability of LFP battery assembly in South Africa, is what would it take the local ecosystem to shift from imports to local production? And we had the service providers speak to a range of different stakeholders, from your IPPs through to Eskom, to some of the automotive manufacturers and different companies across those respective value chains. There's a couple of things that come out of it. Cost is still critical. And I think that's an important thing for us to understand, is that this is this is a very competitive market. And while there are levers that government is trying to pull in order to level the playing field, much of which is dimensioned in SARM and includes things like the reignition of the 12I tax, some of the trade policy measures that are being spoken about, be it around stage consignments or increasing trade duties, price still matters. And so that is the one thing that will need to be navigated. That's why economies of scale are so important in anything that we endeavor in South Africa. Reliability and scale, as I mentioned, is incredibly important. In many cases, supply chain is very, very important as well. And so to the point that I raised about the Europeans, we also are learning that in South Africa, that having access to local producers of goods is incredibly important. We're trying to build that value chain up throughout the way. So I won't go through all of this in detail, but I think it's important, and it is in our broader study, which is available to read on our website, that there are a number of things that need to be considered in localizing. So let me pause here and just reflect on what does this mean for the BESS ecosystem in South Africa. I think the first thing to say is that the energy transition is creating a viable window for BESS localization across the value chain. We've seen that there's going to be about 55 gigawatt hours of demand in Southern Africa in the next 10 years. That's happening. That's a structural feature. It's been driven by the private market. It's been driven by the public market. Capital is being mobilized behind it. But as this happens, that window of opportunity is now. If we leave this for too long, and if we rely on imported technologies for too long, we entrench those imported technologies, and we may see something similar that's happened in other renewable energy value chains and indeed other industrial value chains, where we haven't fully been able to take advantage of the local demand opportunity. Our research has pointed to a couple of things. First of all, demand certainty is key. And that's a conversation that we are raising in SARM with the likes of Eskom to ensure that we at least have clear signals to the market as to when when demand is happening. Because with that, production can be scheduled and scaled appropriately. Import protection is important, and we've advocated for higher tariffs in the short term that can allow the battery ecosystem to develop themselves and scale up to a point after which you can look to scale down some of that. We'll obviously need to ensure that the local ecosystem is there, and so local testing is really important. There is some battery testing capability run by Uyilo through the Nelson Mandela University in the Eastern Cape, but is that enough? That's a key question, and it's something that's being deliberated within SARM. And finally, the supply development is important, and this is where the point I raised about having technical partners is very, very important. I think the one thing, and this is something we've been advocating for, is that policy is moving slowly. Yes, we've had SARM, yes, it's been developed, but there's still quite a lot of work that's being undertaken to help unlock it. And so we've got to try and work in concert with the regulators to ensure that we focus in on those items that are most important in the short term. Obviously, there's a long laundry list of things that we want to help develop the ecosystem in South Africa. But what are the key quick things that we need government to work on? In every economy where industrialization has been successful, it's been done off the back of partnership between the private sector and the public sector. And this sector is going to be no different at all. Obviously, public procurement will play its role. And this is an area where we've been deeply engaged with Eskom. Eskom Green has been established and announced in the last couple of weeks that will look to build its own local battery or manufacturing capability in renewable energy value chains, including batteries. But also Eskom itself will continue to play a critical role in being an anchor source of demand. And my final point is really to say that localizing batteries is part of the just energy transition. We want to ensure that as we embark on the green transition, that we don't lose jobs, that we continue to create them, and that we create them where South Africa already has some of the capability and skills and the ability to scale that up even further. So I think with that, let me pause and thank you again for the opportunity. All of the research that I've spoken to today is available up on our website, and we're available to engage. And as I said, I'll share this website through the Secretariat for distribution to members. Senator Temba, I'll hand back to you and take questions at the end.
Thank you so much, Mr. Shrad. I'd like to just take us to the next session, which actually looks into the technical side. And ladies and gentlemen, allow me to introduce to you Professor Johan Vegas. But maybe just a bit of background about Prof. Before we get there, I think it's important to understand that as we add more solar PV and storage into our grid infrastructure, there's a significant part of power quality that becomes very central to keep, the system stable. Our speaker will take us through what it means actually for PV to be paired with storage, especially as far as power quality is concerned of these distributed energy resources in our grid infrastructure. Before he takes over his session, just a quick introduction of Prof. Prof holds a BEng, MEng, as well as PhD in electronic engineering from the University of Stellenbosch, where he's also an extraordinary associate professor. He also serves as a senior consultant in Eskom's Research and Development Department. His work focuses largely in inverter modeling, grid stability, and support. He's also actively involved in the development of NRS embedded generator specifications, which makes him well placed to speak on power quality in today's session. Prof, over to you.
Thank you. Can you see my screen?
Yes, we can. It's just not on presentation mode yet, Prof.
Okay, let me just figure out. Oh, sorry, I closed it now. Let me share again. Okay, good. Yeah, so I'll be talking about BESS and the grid. And
Was yours, Prof. Thank you.
sorry, you can hear me? Is it everything fine? Hello?
We can hear you,
Yes,
Prof.
we can hear
Okay,
you fine,
okay,
Prof.
thanks. Okay.
Thank you.
Yeah, so from my perspective, I'm looking from the grid's perspective, if we can how much we can accommodate on the grid, and in terms of IBR, and we know that we don't have infinite capacity for grid following IBR. I specifically say grid following, and I'll show that in my presentation. And because we need to supply the customers with reliable power and good power quality. And so we're looking at poor power quality and real reliability issues. But then also discuss opportunities for grid forming BESS, and it will become clear later why I say grid forming BESS. And yeah, what we do is we do research in the dynamics and the non-fundamental frequency issues. So forget about the 50 hertz. I think everybody can. We are aware of just average power and 50 hertz RMS calculations and energy balancing and things like that. But what about the DC, the low frequency oscillations and harmonics and things like that? But BESS is supposed to support the installation and the grid, but it should be done in a specific way, and that should be using advanced control or grid forming control. And I think we are aware of several incidents related to instability caused by high penetration of grid following IBR, and it's been reported internationally. And the most famous one is the 2025 Iberian Peninsula blackout, where more than 50% of the power was supplied from solar, and that's basically IBR, inverter-based resources, and grid following inverter-based resources specifically. And what happened there is that, okay, the first reason why it happened, it's because it was at that stage, it was a significant portion of the generation was IBR based. And the second thing that's important to realize is that they were not aware, they didn't look at the signals, and they couldn't predict it before it happened. And it was a cascading effect. And that will also become clear. So there's two things. We need to understand what is happening on the grid. And the second thing is we need to know what to look at. And we must make sure that the power quality parameters that we're looking at is the right parameters. Do we measure the right stuff? So in the current context, network strength is the per unit short circuit power related to the installed capacity of inverter-based resources. So that can be the combined capacity as well. So so we can easily calculate the short circuit power at a specific point on the grid, and then we can look at what we install, but we also need to take into account or everything else that's installed close by in terms of inverter-based resources to see whether we still have a reliable network. And this is also known as a short circuit ratio. So that equation is very important. It's a short circuit power divided by the combined P of inverter-based resources at a specific location. So what's important is that the increased penetration of grid following IBR lower the short circuit ratio. And also when something happens on the grid, for instance, you have an N-1 condition somewhere upstream, there's a line that need to be taken out for maintenance, or it tripped for some reason, then the S drops. So when SCR drops, we have problems, and I will show that later in my presentation. And with most of the mechanisms involving IBR, when the short circuit ratio drops below 3 at the inverter terminals, the risk is high for inverter-driven instability and subsynchronous oscillation, which is an indication of stability on the grid. We also know that grid forming control of inverters, or IBR, has superior performance at low short circuit ratio. And we are, at the moment, from the research perspective, we are working on specifications, new specifications regarding BESS and grid forming capability, which is not in the grid code at the moment. And I think it's important that it gets in as soon as possible. And I'll also discuss that a bit later. So I think power system stability is important. So we have the traditional forms of stability: rotor angle stability, frequency stability, and voltage stability. So that's basically when your voltage or frequency collapse, or when you have angle changes that too much and you cannot return to a stable operating point, especially in low inertia conditions. So with the inverter-based resources, these are also important because for the inertia lowers and rotor angle stability, risk increases and things like that. With frequency stability is also important with low inertia environments. Then we have electrical resonance stability, where you have line reactance compensated by electric. Can you hear me?
How are you? Good, thanks.
Hallo.
Kijk, kom nou.
Okay.
Prof, I think you're muted.
Yeah. Okay. To come back, electrical resistance stability, if we have series compensated lines, we can create a resonant point. And when you have negative damping at that resonant point, the system can become unstable, and things that typically, or equipment that typically generate that negative impedance is torsional interactions on generators, especially the nuclear generators, Kuberg, and then you have the induction generator effect. But the third one is inverter-based resources creating negative resistance at certain points. You can now also have mechanical resonance stability, where you have a torsional interaction and a negative inverter creating a negative resistor to that torsional interaction at the torsional interaction frequency. So, but what we are going to look at today is just pure IBR control instability or control interaction. It's inverter-based driven stability without anything else on the grid. It's not related to series compensation on the grid. It's also not a torsional interaction, mechanical resonance. It is purely related to the control system of IBR, and specifically grid following IBR. And the two main aspects here are things that causes instability is in the power control loop. So in a typical IBR control, you have a power control, and this is just a normal standard feedback control system. And you have a voltage control loop, and these two control loops can interact with one another. Different plants can also interact with one another. And as soon as these interactions occur, then you have one variable, for instance, voltage in this case, something that can change, and there's interaction between the two control loops, and it becomes a nonlinear system. Then typically with IBR control, you also have time delays. For example, in a typical IPP where you have a power plant controller, you have communication delay between the inverter controller and the power plant controller, and then you might sometimes do the opposite of what you should do due to the time delay. And that you can also model mathematically in the S domain, the frequency domain. It's a exponential function, and that, yeah, in control systems, you can model that as a non-minimum phase system where you have a zero and a pole on the right hand side of the complex plane, and which can create negative damping. So if we model from a research perspective, a very simple grid inverter-based resource system, it can be, in the most simplest way, be modeled as a Thevenin equivalent grid with a constant impedance, a grid impedance, and then a Thevenin equivalent current source and a susceptance there. And when you look into the control systems of inverters, then you will see that due to the control of the inverters, these things that happen, you can get a negative impedance. So the inverter creating a negative impedance due to things like control interaction and time delays, and also current controls and PLLs and things like that within the inverter at different frequencies. So then you look at this equation, and as soon as you get a zero underneath of the line, you'll see that the influence of a current reference. So in principle, a grid following inverter is a current source, and there's a transfer function, and then these impedances forms part of the transfer function. And when that portion below the line, the numerator becomes zero, then you get instability. What is important to note here is that two things influence the current that you inject into a grid. So the grid following inverter is a current, can be modeled as a current source, and the two things that is at play here is the reference that is created from a power reference, for example, or a voltage reference. You get a current reference, And then the transfer function, the second one is that the grid is also changing the current shape. So what it means is, with grid following inverters, you can start following yourself if that impedance become too high, because you change your voltage, the voltage at the point of common coupling more than the grid changes it. And that typically happens when your short circuit ratio drop below 3. So that is a basic principle of instability when you have these purely inverter driven instability problems. This slide just shows that at different frequency you get different parts of this inverter-based resource control systems at play. So and you can analyze this by in the different control systems. Look at when you can create the negative impedance, and at high frequencies, harmonic frequencies is also important. Then IBR parameters, grid parameters, sampling delays, and the current controller influence these harmonic frequencies. This is not important for today. Then you get subsynchronous oscillations associated with IBR, and then there's two categories with these subsynchronous oscillations. These are the low frequency oscillations. You get the near synchronous frequency oscillations, and then the low frequency oscillations. And the near synchronous frequency oscillations, the PLL and the DC voltage control loop inside the inverters play an important role. So PLL parameters and DC voltage control parameters are important to set. But the one that I want to look at today is the low frequency, because that is the one aspect that we suspect is causing the most of the issues at the moment on the grid. And what an inverter-based resource basically does, it controls that parent power. Parent power consists of a P and a Q, real power and reactive power loops, and in the inverter control, it's normally assumed that these two are independent, and you can also have a voltage control. Set typically IVP in voltage control or a reactive power control. And I will show, you can go through the maths. I don't think there's time to go through all the maths, but in real life, this V that forms part of the open loop transfer function is not a constant. It can, for example, in the P loop be influenced by the V loop, and the V loop the IR control forms again part of the V loop, and in that way, if you don't control or manage these interactions, you can get these problems. And if you elaborate further on the interaction between the P and the V loop, for example, in control systems, you can see that this is the way they interact, and you can go into the maths, but the important thing here is that the interaction between the P and the V loop is related, is a function of X and IR, and X is grid strength, and IR is the amount of active power that you inject into the grid. So, and that is then non-linearly coupled with the P loop again. Okay, we can go into further maths and analyze this further, but I'm not going to do that. We normally look at the small signal instability when you look at this, because it's a non-linear system. And let's look at the time delay. This is the second one. And if you remember, those of you that did control systems at varsity, when you look at the root locus, you can see that a time delay in a control system, and this is typical in inverter control, where you have signals that need to be transported from one system to another system. You get zeros on the open loop zeros on the right-hand side of the complex plane, which end up in poles at closed loop poles at the right-hand side of the complex plane. And if your system big gain becomes too high, then you end up on the wrong side of the complex plane. The right-hand side of the complex plane, it's an unstable system because you have negative damping. And the X play a big role here. So if you increase, so if you have a line that drops out, X increases, then you end up with instability if those time delays are too long. And what's important here is that even if you have a BESS, for example, that's supposed to support the grid in grid following, just to come back to grid following versus grid forming, these are all grid following examples, which means that a current source is injected into the grid. It relies on a control system to give a current reference. A grid forming inverter acts as a voltage source, so it spontaneously delivers its current into the grid. So that's why grid forming is so important with BESS. We from a grid support perspective, we want spontaneous response. We don't want to have a control system that need to decide first what to do. We want that spontaneous interaction. And in the real world, obviously, it's not that perfect. That grid forming with BESS in the ideal world will be the perfect solution to solve problems. But if you have a typical IPP where you have a power plant controller and then inverter controllers, and there's communication between these two, then you defeat the purpose. We need to start doing these things on inverter level. Inverter should spontaneously control. It doesn't need. We don't want to wait for a command to come from the power plant controller cursor, for example. And this is where the grid code need to come in. Grid code doesn't really specify dynamics at this stage. And if we don't have, because this time delay is also applicable to grid forming inverter as soon as you have different levels of control in your system. So that's why bandwidth and on the different levels, so and transport communication delays are very important when we start to specify these systems. So ideally, you want a single inverter connected to the grid without the power plant controller behaving as it should behave as a voltage source with a battery energy storage system. So I just want to give you a few examples. So we are limited with time. I'm just running through a lot of things at the moment. This is just real cases that we measure, and remember that when it comes to SSO subsynchronous oscillations, we don't really specify that in our SO48. It's not something that we look at. So that is, I think, one limitation. We need to start identifying these events. So the events that we captured was just coincidentally. We were looking at a few things, and then we see what happened is what I'm going to explain now. So on one of our wind farms, we had a trip, and we looked at the protection relay, and there was a rock-off relay that did its thing, and then we could get data from the rock-off relay to see what happened. So in this case, one of the lines upstream, one of the transmission lines tripped due to a snowstorm, and then the short circuit ratio of the wind farm dropped below 3. As soon as it dropped below 3, the SSO started to happen. The rock-off relay that look at the rate of change of frequency, not really SSO, picked it up as exceedance, and it tripped. And there you can see in the voltage and the current waveforms, or the current and the voltage waveforms at that plant what happened. The current dropped to 0, and when it dropped out, the voltage was stable again. So that was one case. Then about 2 weeks ago, we were measuring power quality on one of our distribution feeders in Eskom. And the reason why we measured power quality is just on the Orange River, we have obviously a lot of farmers using VSTs. And we are not really concerned about the harmonics generated by the SSEGs, but more about the VSDs that large motors uses on these feeders. And there's a high penetration, obviously, such a penetration of SSEGs on these feeders with large VSDs. So sometimes, yeah, so then we were measuring harmonics, and then I realized that there was severe flicker on that particular feeder. And when we realized it by looking at by seeing that the light flicker basically in the lodge that we stayed in, and when we measure it, this is the oscillations that we saw in the current and voltage waveforms on that particular feeder. And when we start investigating, we realized there was a line in the Northern Cape out. It was the Aggeneys Pulpits line that was out for 1 or 2 days for maintenance. And if you look at this picture, there's the main transmission substation that feeds this area from 2 sides, from Aggeneys, Aries Aggeneys, and then from Aries to this side to Typits and Renosterkop. So they took out that piece of line, and normally that there's normally open point at Renosterkop, and to maintain that line, to do maintenance on the Aggeneys Pulpits line, 22 kV line, they close that normally open point, and they feed Concurrency's Pulpits basic substation from the other side, much longer distance. 132 kV line instead of a 220 kV line, and the SCR dropped significantly. It's on the end of that feeder, and suddenly the SCR short circuit ratio at that location dropped to below 3, and this is the short-term flicker that we measured during those 2 days, and you can see that the flicker at Skydrift, this was longer at Skydrift substation, increased to 15, and when the lights flickered, we realized that it's actually one of the Concurrency's 2 solar farm that started to oscillate. So thing is here, we didn't really measure for SSO, but by looking at flicker, we could see there's SSO. So these things start to happen with a high penetration of PV and grid following inverter-based resources on the grid. And we need to start understanding the risk. And we must make sure that the grid is reliable. Yeah, so that is a SSO problem. How much time do I still have? 5
We've
minutes.
exhausted our time, Prof, but I think I'm happy
yes.
for you if you can just wrap it up for us. Thanks.
Yeah, so I discussed SSO. So from Eskom side, what's important here, we need to look at what's happening on the grid and look at the non-fundamental frequency issues. So we also looked at harmonics in another study, and we could show that grid forming BESS improve harmonic performance. So what we need to do in future, while we need to develop specifications for BESS, so that we use capability of grid forming to compensate for things like SSO harmonics, because BESS grid forming acts as a voltage source, and that's what we want on the grid to support the grid. So that's a message that I wanted to convey. We have issues. Let's use grid forming capability and use BESS to sort out these things. So in this study, we showed that the superior performance of grid forming with the real installation in terms of harmonics. Yeah, and then just to conclude, what we are doing is we are developing grid forming BESS specifications at the moment, and we basically use a FinGrid. So if you want to, so we don't have a formal specification yet, but we basically use these two documents, which are very good documents in developing these requirements or specifications. That is the FinGrid and then the Australian specification for grid forming inverters. So these are the two documents if you want to know more about it. It's basically dealing with response, damping out oscillations, and things like that. That basically concludes what I wanted to say.
Thank you so much, Prof, for that presentation. I think as we move along to the Q&A segment, I would allow our colleagues. Thank you once again for all our speakers. I will allow colleagues, maybe you can turn your mics on as well, just for you to take questions from our speakers. Thanks, colleagues. I see there was one hand up. Or maybe just before, while we're waiting for hands, I'd just like us to go through some of the questions that within our chat section. But I see Maluleke there has their hand up. Maluleke, maybe you can just come in through this section. Over to you.
Good day, everyone, and thank you very much for the wonderful presentations. So I've got a few questions. I will just ask all of them to the directed respective speakers, and then maybe you can take it from there. So the first one is with regards to the VRFB, that the technology showed a lot of strengths throughout the presentation, but only on the energy density it was low. So I want to know what's the impact of this in real life cases. Is it bigger size batteries? What does that mean if it's got a much lower energy density? What are its limitations in terms of practical application? And then for Prof, you mentioned a lot of instabilities that are caused by the GFL IBRs. And then what I want to know is for someone who's a microgrid installer or SSEG, what kind of specifications should they look out for in terms of when purchasing inverters or IBRs? Yeah, that's it from my side.
Thanks, Maluleke, for your questions. I'd like our second speaker maybe to go through it. Mr. Katrada, do you want to take a question?
Sure, very happy to. And Maluleke, thanks so much for the question. Yeah, look, I think on VRFB, you've absolutely got it. So that is the one challenge of VRFB at the moment, that because of the low energy density, it means that you need a bigger footprint for the batteries. And so what that means in practice is that it's largely going to lend itself to large scale utility infrastructure rather than CNI type of infrastructure, and certainly not residential. And so I think that's sort of my point that I make around horses for courses. You'll find that VRFB is going to be really good for long duration energy storage, where it is big utility scale because of that footprint that's required. Hope that covers it. Happy to take a follow-up if there's one.
Yeah, with future research, do you see that energy density component increasing, being better, and still maintaining the rest of the qualities?
I'm not an expert on all of it, but my understanding, Maluleke, is that look, there's only so far you can take energy density just based on the chemistry that's available to you and how the battery works. And so while there might be an opportunity to improve it on the margins, I mean, given where it is relative to other technologies, I don't see it competing with LFP type of applications, because LFP has a much tighter energy density or much higher energy density, as does NMC. It's unlikely to come into that range, but it may be able to improve by some fraction over the next while. But again, there are limitations based on the technology. Thanks, Ntemba. Hand back
Thanks
to you.
for that. Thanks, Mr. Short. Maybe the second question I'd like the
Yeah,
second question was to Prof.
I
right?
think it's for
Thanks.
me.
Yes,
Um,
Prof. Thanks.
Yeah, so yeah, I think that's a good question. I think we lack a good specification for microgrids. That's why we are busy with some of this research. So I would so yeah, so I know that grid forming inverters perform better in terms of certain things like if and some of the manufacturers also already have the hybrid inverters or BESS inverters with grid forming capabilities, and we've tested that. So in terms, for example, harmonics, I don't want to mention manufacturers now, but when we look at harmonics, we could see that what from a network service provider, what we want to see is that the customer deal with his own harmonics. So what happens typically is that you will have in a microgrid and a grid following inverter connected to the grid. When you the grid following inverter only provide a pure sinusoidal 50 Hz current waveform. So all the harmonics generated by the load goes into the grid. And for that reason, we limit the capacity, the nameplate rating and install capacity in a typical installation, because we still need to absorb all the non-50 Hz currents. When it becomes grid forming, those harmonics will just be shared amongst. It will follow the lowest impedance path, and in a low SCR scenario, it will flow into the inverter. So harmonics generated by the load will flow into the customer's own inverter, and we don't need to deal with the harmonics, because what happens when the harmonics flow into the system, it basically just flow to the next customer, and we need to obviously protect all our customers. But we are working, we are researching these aspects, and we hope to get better specifications in future. So I think the grid code is lacking certain things in terms of dynamics, but also the SSEG specifications when it comes to grid microgrids.
Thank you, Prof, for that response. There's also one question in the chat, especially for Mr. Katrada, and it's from Matthews, and it reads, you mentioned that public procurement is an important factor in demand for BESS outside of Eskom, which is critical in this, and where else do you see public procurement playing a role?
Thanks, Senatemba, and I did respond in the chat, but also happy, I think, for the broader community also just to speak to it. So I think there's probably three sources. Obviously, there's Eskom's direct demand as they localize it and they build up grids, but there's also the BESS program, the battery energy storage program, similar to the REAPs, which have been established, where there's an opportunity to introduce localization and local content requirements. From my understanding on the BSIPs that have been done, the tenders that have been done thus far, it hasn't included anything on localization, but I think there's an opportunity to do so, particularly as we build this out. I think the third area is, and this is subject to a bit more investigation, is colleagues may be familiar that there's a new Public Procurement Act that has been signed by the President, and we're waiting for the final regulations before it comes into operation. That Public Procurement Act now clarifies the role of what's referred to as designation. So the Act says that you are allowed to designate sectors and products, so that if any state-owned entity is purchasing those products, it needs to come from local manufacturers up to a certain threshold. And I think there's an opportunity to consider looking at some of the BESS system components as well, because what we're likely to find, particularly as some entities invest in their own BESS capacity, that they will be purchasing it directly. And so designation may be and also an important tool. And so that's something that we will be engaging with governments around.
Okay. Well, thanks for that. Maybe just to take one last question before we close this section. And this is directed to Prof. Pori Maliane. The question reads, what is the acceptable measured value for, or the standard short circuit ratio for performance evaluation of synchronous inverters?
Yeah, so that is, I think, the most important question. And that is what we are researching at the moment. So above 5, I think, is safe. So if you can calculate, you need to calculate the equivalent short circuit ratio, that combining. So there's an equation for that I think is a Segre or a IC method for calculating the real equivalent short circuit ratio and combining all the IBRs in the region. So to make provision, because if you drop below 3, you will probably become unstable. So a 5, around a 5, I think research will show what it should be to make provision for N-1 conditions. But I think at the minimum when you design should be 5. But we will obviously get that into the specifications as we go along. And what will happen, I think, is if it goes below 5, you will specify that then the technology that you install must be grid forming. So from a network perspective, we want the BESS systems to support the grid. So it doesn't. So we just need to do it in the right way. We will typically say below 5 you go for grid forming, above 5 you go for grid following, because grid forming above 5 is you have other issues, because then you connect to very strong voltage sources together, which can create other issues. So that will typically be the specification, something like that, eventually.
Well, thank you so much, Prof, and thanks to all our speakers for answering and taking through these questions. I'm not sure if I've covered all of them. Without any further ado, colleagues, I think I'd like us to just move into the last but not least. I see time has went by, but I'd like us to further just take this opportunity to have our inaugural of the chairperson for this working group, who will briefly just highlight it to us in a high level, just I think just some of the focus areas and objectives of this working group. But you'll note that we've already indicated some, maybe just without any further ado. Ladies and gentlemen, allow me to introduce Mr. Sydney Pagati, who is a co-founder and CEO of Eigen, and also has which is co-founded and helped, to scale in one of the country's growing storage companies. And he has about nearly 2 decades of experience across the energy and technology, as well as financial services. And his earlier roles included, being at Investec, private bank, as well as Freedom One, South Africa's pioneering lithium battery manufacturer. And his background also is quite interesting, because he's building businesses and developing new markets, and it's quite interesting to have him in this working group. Sydney, perhaps just a brief introduction. I think just noting time as well. I'd really appreciate it if you can come through at this point.
I think, thank you for the intro. I'm an entrepreneur in the space. So I've had the pleasure of seeing the space growing from strength to strength. We have to be clear that there are a myriad of challenges that obviously surround the space, and I'm glad that there are forums like this that allow us to further enable and localize the participation of energy storage. It's a key part of what we do, especially when we're talking about stabilizing our grid going forward within the Southern African region. From a background perspective, Eigen was founded in 2018. We've since done about 50 megawatts. we've scaled from doing residential opportunities all the way up to about CNI level, and we continue to grow in this market. We have seen all the challenges that come with being in a market. And being part of a working group means that, we can start influencing exactly how this market should actually be going forward and how people can then start participating and, breeding those localization efforts, which ultimately then lead to job creation. So I think going into the objectives of the working group, it's quite important. Snetenda, can I just request that you run the slides on your side? Just having a little bit of a challenge on my other screen. Hi, can everyone hear me?
Yes, we can hear you.
Yeah,
We
sure.
can hear you, Sydney. Perhaps you
Sure.
can just read them for us while I'm trying to share for you. Happy
Not a
to do
problem.
that. Thank you.
In just talking about this, I mean, we have to run through pure objectives. Why does BESS matter? The strategic objectives around that. There was a survey that was encountered as well. Just looking at why BESS matters, firming up our grid. There's a lot of growth that has happened within utility scale storage and also CNI. If I take into account just what I've seen in the market, there has been a shift, specifically with just us doing mainly grid tied. In the past, we have seen a dramatic shift, especially in the last 4 years, where we've seen solar plus storage being included in most projects. Regulatory gaps and compliance gaps, they are there. Our baseline understanding of how to meet some of those compliances has been a challenge. We are seeing a huge uptake of electric vehicles, and we still don't know what the net effect of that is going to be on the stability of our grid. But it also leads us to other opportunities that are likely going to come off that, relating mainly to what are we going to do with these batteries when they get to end of life? How are we going to repurpose and recycle them? And on top of that, understanding that the growth of the EV market also means that we're going to also have a lot of instantaneous demand at a given point in time when all of these fleets have to charge. When we start just diving into that, I've seen in the more recent times, Sunny South Africa has come out with trucks with average battery packs going from 120 kilowatts up to 500 kilowatts. That's going to create its own constraints at the point when they're charging. Understanding this as well is from a South African perspective, BESS enables reliable and flexible storage. From our side, we also need to try and figure out how we can unlock more BESS and talk about how we can overcome some of the grid constraints. We also have to drive the process around industrialization. It's important that we participate in this market that is developing quite rapidly. And I was listening with intent, especially to Mr. Katlala, saying that our market is likely to grow to about 55 gigawatts. What is our participation? How much of that have we carved out for South African companies? And what will it mean to the downstream beneficiation as well? And how many jobs can we actually quantify and say, with this amount of level of participation, these are the actual jobs that can be enabled by this industry. Would love to have more discussions around that as a working group. From an objectives perspective, and can we go down one more? In terms of slides? Yeah. Just running through some of the key objectives, obviously from a working group perspective, is to advocate for clear enabling policies and technical standards and engage government and stakeholders around unlocking BESS and local participation, technical standards, and also just having a good understanding with market intelligence. What happens, that data is not easily accessible. I know that there are reports that are out in the market. I know I now have learned that there are reports from LSF and Green Cape as well, but they're not easily accessible to everyone who's participating in this market. We do need condensed forms that are easily accessible, given widely to everyone as well. When I typically look at some of the things that are relating to the survey, what has been highlighted as some of the pain points and priorities of the industry refers to skills. Gearing up skills base in South Africa is traditionally difficult. There is a gap between us and our tertiary institutions, and we need to figure out ways of bridging that gap through better programs, internship programs. You always find that skills deficit, it takes about 6 to 8 months to get anyone up and running within the sector. Finance, there is a clear finance gap. I've seen it both from an entrepreneurial perspective when we're starting these businesses, also relating to finance for funding these projects. As much as we say in South Africa that the institutions exist, they're not as easily accessible, and also their requirements are such that our industry is normally lagging behind in meeting those and getting into that entrepreneurial environment of creating these businesses that allow us to participate. From a technology standpoint, I think we are somewhat there. There are things that we can still learn. We have not industrialized, but on the upstream elements, things like creating EMSs, developing on the technology side, especially on software. South Africa is very strong, traditionally strong on software. So based on that, I think there's still a lot. On the hardware components, we will need a lot more support in order for us to start creating those industries, and especially capital support, which will then obviously lead up to localization and obviously standardizing of the market. There is need for standardization. We see it in the market. Everyone is doing their own thing, and best practices are not always ensured in terms of how we go to market with these solutions. And even when we are importing, we are not sure that we are importing the best quality of product as well. As a reality, when we talk about testing capacity, the need for us to increase testing capacity in the country is absolutely vital. I speak of the players that are already in this market that I know off the top of my head, the likes of Blue Nova, Freedom One, iGen, Solar MD, Averge. At this point, they are more capacitated than even some of our testing institutions, the likes of Wheelo, and which is a problem. And when you look at the cost currently, there's a reality that in order for you to have verified testing that allows you to be globally competitive, you have to send your product overseas. And there's a bottleneck that is created by that, a bottleneck of 6 to 12 months, and an expense that businesses locally would have to incur, anything within the region to $30,000 to $120,000, which obviously does act as a barrier to entry, which we would need to overcome. From our side, in terms of focus areas and why I'm thrilled to be part of this, is that we are going to be looking at policy, licensing, tariffs, grid connections, technical codes, safety, standards and skills, and methodology around how we can best fulfill the localization value chain and the incentives and what jobs are going to come of that. So being part of this working group is an honor for me, and I'm hoping we can get more people to participate. Yeah.
Thank you so much, Chair. I think that was quite insightful. Perhaps just to wrap this up, Zimkhitha, I know you're in the call, just to give a quick overview of how members can engage with us, just to take these conversations, this conversation further, but most importantly, also just to ensure that potential members and members, they become part of our working group as we move forward. So I'd like to just hand it over to you, Zimkhitha, just to quickly share with our audience as to how they can participate. And just thank you once again, colleagues, for just being in the call, despite us being over time. We really appreciate your time.
Thank
Zimkhitha,
you.
over to you, ma'am.
Thank you, Snetemba. Can you confirm you can hear me?
We can hear you. Thank you.
All right. Thank you very much, to our esteemed presenters. So my role is just to inform members on how to participate in this working group and any other working groups that we have at SAPVIA, as today is the official launch for the BESS working group. So SAPVIA is a member-led association, and therefore our working groups are these member-driven forums where industry comes together like we are doing today, but with the intention of coming up with tangible solutions for the industry. So to get involved or to participate in our working groups, I've put the link in the chat box. Our working groups are open to SAPVIA members, right? If you are not a member yet, this is an opportunity where we can change that. Membership is open to all players across the PV and storage value chain. So I've put the link in the chat box. Whether you're sure if you are a member or not, kindly click on the link, fill in the information, and not necessarily just for the BESS working group. If you are a member, indicate which of the other working groups that you'd like to participate in. We currently have 9 working groups at SAPVIA, being distributed generation, grid access, environmental, residential PV, manufacturing and localization, gender and economic development, skills for PV, operation and maintenance, and BESS working group, which is the current launch that we are participating in right now. So yeah, click on the link in the chat box, fill in the information, and then our team will get back to you in terms of being submitted or added into the database. Then we will send you calendar invites for the working group meetings for the year. So when you are confirmed, then you will receive a calendar invite series for the year, just to help you to prepare. Thank you, Chair.
Thank you, Zimkita, for that. And perhaps maybe without any further ado, I'd just like to thank everyone once again. But maybe before I close, I'd just like our CEO to have or share any parting shots with us, just to grace our session as well. Tabi, any closing remarks for us? I'd really appreciate them. Not sure if it's from my side, but I see Tabi is muted.
Yeah, maybe I can just assist
We can just close for us. Okay.
Yeah,
Over to you, Sim. Thank you.
Let me just close. Thank you, colleagues. Thank you for your time. And I think it is really, really exciting to see the demand and the interest on this working group. But maybe let me just first and foremost thank our speakers. Felix, thank you so much for sharing what you're doing in Africa, for give us the outline on the work that you're doing in Malawi. And we're looking forward in actually engaging with your global knowledge platform. And thank you, Ishrat. I think everyone agrees that localization is the key, and how you painted the picture and the need of that is highly, highly appreciated. And obviously, thanks to Prof. Prof, you know, you basically told us that let's not look at it as batteries, but there has to be grid forming batteries or grid forming BESS. And thank you for that. To our new chair, we're really, really excited that we will be led by someone in the space who has cut his teeth. And we together will be shaping the industry going forward. Thank you to everyone who was able to stay the extra minutes. We really, really appreciate it. And from the SAPVIA team, we will want to wish you the wonderful day. And I believe that our next meeting for this working group is on the 14th of July. But as Zimkita has said, we will communicate with those who've indicated the interest. Thank you, and we can close the meeting. Thanks.
Thank you,
Thank you,
Sim.
Chair. Thank you,
Thank you,
everyone.
everyone, for joining us. We will share the presentations as well as the recording of the sessions.